Definition of software-defined networking. Software-defined networking technology is an approach to network management that enables dynamic, programmatically efficient network configuration in order to improve network performance and monitoring, making it more like cloud computing than traditional network management. SDN is meant to address the fact that the static architecture of traditional networks is decentralized and complex, while current networks require more flexibility and easy troubleshooting. SDN attempts to centralize network intelligence in one network component by disassociating the forwarding process of network packets from the routing process. The control plane consists of one or more controllers, which are considered as the brain of SDN network, where the whole intelligence is incorporated. Example: Software-defined networking application is a software program which is designed to perform a task in a software-defined networking environment. It is that approach to computer networking that not only allows network administrators to change programmatically, control, initialize, and manage network behavior dynamically through open interfaces, but also provides the concept of lower-level functionality. SDN applications also help in enlarging and substituting upon functions that are accomplished in the hardware devices of a regular network through firmware. Switch-based SDN. The idea of SDN was originally based on the switch-based model. The switches process packets with a system like OpenFlow, which dictates the behavior of the network switches. This provides a central control point that manages how the switches handle network traffic. The model can use a mix of controllers and switches that support compatible versions of OpenFlow. Businesses can choose between virtual or physical OpenFlow-enabled switches. Hybrid SDN. The hybrid SDN model combines two or more networking technologies in a single environment. A network manager, for instance, can configure the SDN control plane to manage specific traffic flows, while traditional networking protocols manage the other traffic flows on the network. Hybrid SDN uses a variety of networking types, including VPN, Ethernet, MPLS, among others, to connect multiple locations and workers. A hybrid SDN approach provides flexibility by using the newest SDN technologies to meet the demands of each location. SDN overlay. The SDN overlay model tunnels through the physical network to run multiple virtual network topologies on top of an existing infrastructure. This allows a VN to be a Layer 2 or Layer 3 network, and a physical network to be a Layer 2 or Layer 3, based on the type of overlay. Under the overlay model, VN configurations determine higher-level policy, and physical networks undergirding the architecture forward packets. Since virtualization takes place at the edge of the network, the Layer 2 and Layer 3 network do not change nor need configurations to maintain the virtualization of the network. Moreover, the overlay optimizes network resources by distributing bandwidth into channels and allocating each channel to a device or service. In addition, the overlay can boost network efficiency and productivity by performing various tasks typically reserved for network administrators automatically. Security services. The modern virtualization ecosystem supports specific virtual service that is running within the network layer. It means an incorporating function like NV into SDN platforms. This type of network security creates a genuinely proactive environment that is capable of risk reduction and responds to the incidents very quickly. Whenever a violation occurs, every second is quite critical to stop the attack. It is also essential to identify the attack and to ensure that other network components are safe from the attack. As the organization in the modern era becomes even more digitized, and as the network layer becomes even more critical, we will see even more attacks and more advanced persistent threats. You will be able to create a more proactive environment that can respond to the changes if you integrate potent services into the SDN layer. Network monitoring and intelligence. Modern SDN technologies help in abstracting one of the most critical layers within the data center, that is the network. Network architectures are very much complicated and must handle a lot more data than ever before. This means it's critical to know what is following through your environment. Do you have remission issues on a port? What will happen if you are running heterogeneous network architecture? Or, are you passing a lot of traffic and are heavily virtualized through the network architecture? All these challenges or issues are diminished if you have a solid network monitoring and intelligence layer. However, you also gain benefit and true insight if you integrate these technologies into your SDN architecture. Even optimization, alerting, hypervisor integration, port configurations, and traffic flow can be incorporated into network monitoring and intelligence technologies. Also, these types of agile systems will also help you to monitor network traffic between your cloud ecosystem and your data center. Bandwidth management. With the help of SDN applications, operators can use bandwidth management to ensure the end users to receive online video watching and optimal browsing experiences. This SDN application can also monitor the bandwidth requirements, then provision user flows to match the latency and bandwidth requirements of the Layer 7 application. This type of application-aware approach to bandwidth management will also ensure a better user experience with zero buffering through better video playback. At this stage in the game, there is little doubt that SDN is becoming a reality in operator networks. Centralized network provisioning. Software-defined networks provide a centralized view of the entire network, making it easier to centralize enterprise management and provisioning. For example, more VLANs are becoming part of physical LANs, creating a Gordian knot of links and dependencies. By abstracting the control and data planes, SDN can accelerate service delivery and provide more agility in provisioning both virtual and physical network devices from a central location. Holistic enterprise management. Enterprise networks must set up new applications and virtual machines on demand to accommodate new processing requests such as those for big data. SDN allows IT managers to experiment with network configuration without impacting the network. SDN also supports management of both physical and virtual switches and network devices from a central controller, something you can't do with SNMP. SDN provides a single set of APIs to create a single management console for physical and virtual devices. More granular security. One of the advantages of security-defined networking that appeals most to IT managers is centralized security. Virtualization has made network management more challenging. With virtual machines coming and going as part of physical systems, it's more difficult to consistently apply firewall and content filtering policies. When you add in complexities such as securing BYOD devices, the security problem is compounded. The SDN controller provides a central point of control to distribute security and policy information consistently throughout the enterprise. Centralizing security control into one entity, like the SDN controller, has the disadvantage of creating a central point of attack, but SDN can effectively be used to manage security throughout the enterprise if it is implemented securely and properly. Lower operating costs. Administrative efficiency, improvements in server utilization, better control of virtualization, and other benefits should result in operational savings. Although it is still early to show real proof of savings, SDN should lower overall operating costs and result in administrative savings since many of the routine network administration issues can be centralized and automated. Hardware savings. Adopting SDN also gives new life to existing network devices. SDN makes it easier to optimize commoditized hardware. Existing hardware can be repurposed using instructions from the SDN controller, and less expensive hardware can be deployed to greater effect since new devices essentially become white box switches with all the intelligence cantered at the SDN controller. Cloud abstraction. Cloud computing is here to stay, and it is evolving into a unified infrastructure. By abstracting cloud resources using software-defined networking, it's easier to unify cloud resources. The networking components that make up massive data center platforms can all be managed from the SDN controller. Guaranteed content delivery. The ability to shape and control data traffic is one of the primary advantages of software-defined networking. Being able to direct and automate data traffic makes it easier to implement quality of services for voice over IP and multimedia transmissions. Streaming high-quality video is easier because SDN improves network responsiveness to ensure a flawless user experience. Illustrative example. These are some of the companies offering solutions and offerings for software-defined networking. Arista Networks, Cisco, HPE, Juniper, Nokia New Age Networks, VMware.